Okay, welcome back Pre-Calc Plus students. Today we are going to cover section 3.4. We're going to do the first part of it. The entire section covers exponential and logarithmic equations. Today we're going to just focus on the exponential equations. So we're going to start off with a little review from the past because you do want to look for this. When you have an exponential equation like this where you can get the same base, we did this in the past, then that's probably the best way to go about it. Right? The simplest way doesn't even require a calculator. So because 16 can be written with the base of 4, I can solve for x by getting the same base on both sides. 16 is 4 squared. And then I can just set the exponents equal to each other. So x is equal to 2. Okay, very basic. But keep your eye out for it because you might see some of the problems where you can do it this way and get the same base. Here again, when I see 2 and I see 32, I know I can write 32 as 2 to the 5th. I can rewrite a half. 1/2 is 2 to the negative 1st, and then that's to the x power. And remember, when we have a power to a power, we multiply. So this is 2 to the negative x is equal to 2 to the 5th. So negative x is equal to 5. So x is equal to negative 5. Okay, over here we have, let's see, a base of 4 and 64. 64 can be rewritten. Right, that's 4 to the 3rd power. And once I have that same base, set my exponents equal to each other. So I'm adding 7, dividing by 2, and I get x is equal to 5. And remember, you can check these like any other algebraic equation, right, just by plugging back into x and making sure you get the same result. Okay, let's move on to the next type. Now, these are all in base E, okay? But it's the same procedure. Doesn't matter what the base is. So as long as you can get the same base, it doesn't matter what that base is, you set the exponents equal to each other. So here I already have base E on both sides. So I can just take the x and set it equal to x squared minus 2. Since this is quadratic, I want to move all my terms to one side in order to solve. So I'm going to subtract this x from both sides. So that'll be x squared minus x minus 2. And I can factor this. So this would be x minus 2 and x plus 1. So I have two solutions. And this will still be set equal to 0. X is equal to 2 or x is equal to negative 1. And if you want to try the check, if we plug in 2, we'd get e squared is equal to e, plug in the 2 for x, so that's 2 squared minus 2. 2 squared is 4 minus 2 is 2, so I get e squared on both sides. If I plug in the negative 1, I get e to the negative 1st is equal to e negative 1 squared minus 2. Negative 1 squared is positive 1. Positive 1 minus 2 is negative 1. So again, on both sides, I have e to the negative 1st power, so it checks out. Okay, now here I have a base of e, and on this side I have a 2. So this is the first one where we cannot use what we did in the past. This will require the use of logs and the use of a calculator. So there's two ways you can look at this. One way would be to take the natural log, remember it's base e. E is the natural base, okay? So we have to use natural log to undo it. Right? Those are the inverses. E to the x and natural log of x are inverses of each other. So I can take the natural log of both sides, so it's natural log of e to the x is equal to natural log of 2. The natural log of e to the x, remember from our properties, is just x. So x is equal to the natural log of 2. And then this I would have to calculate on my calculator. And I get a decimal. Usually you're asked to round to the nearest thousandths. Okay, so to the nearest thousandths, it's 0.693. Now the second way to look at this is exponential form. So you could look at it as though you're just switching this into log form. So it's also, again, natural log because it's base e. The natural log of what it's set equal to, which is 2, is equal to your exponent. So we end up with the same equation, the same thing that x is equal to. So you can look at it either way. I often look at it this way, where I'm just changing it into log form. Okay, here we have 4 times e to the x minus 1. So the first thing we need to do, we want to get it into that exponential form, so we have to get rid of this 4. And since this is a product, we're going to divide. So I'm dividing both sides. So I have e to the x minus 1, that looks like an L, is equal to 15. Now I have exponential form. I have a base to a power equal to something else. So now I can go into my log form. So it's the natural log of 15 equals my exponent. So on my calculator, I'm going to take the natural log of 15 and then I'm going to add 1. And this is why parentheses, having parentheses versus not having parentheses is so important. When I see this calculation, this is not the natural log of 16. I'm taking the natural log of 15 and then I'm going to add 1 to it. So on your calculator, if you plug it in, the natural log of 15 is 2.708, and then adding 1, we get 3.708. Okay, so here, again, just put it into log form. So it's the natural log of 30 is equal to x. And if you plug that into your calculator, you should get 3.401. Okay, for letter B, we have a couple of things going on. We have a coefficient of -3 for the e to the x, and we also have this 5. So we need to do 2 steps here to get it into exponential form. Our first step, we're going to take care of the 5. Again, there's no parentheses here, so this is not 5 minus 3. Don't look at it that way. What we want to do is subtract the 5 from both sides. So that cancels out, and I'm left with -3 e to the x is equal to -3. Then my next step is when I divide. So -3 over -3 is 1. So I get e to the x equal to 1, and actually for this one we don't need a calculator, right? So to get that 1, what does my power need to be? Hopefully you said 0, right? Anything to the 0 power is 1. Okay, now here we have a base of 2, okay, being raised to the t plus 5. We have 6 times that, and then we have a 4 added on. So again, my order is always to do addition or subtraction first, so I'm going to get rid of this 4. So I'm going to subtract 4, subtract 4. So I have 6 times 2 to the t plus 5, oops, is equal to 7. My next step is to divide by the 6. So here the 6's reduce out, and I have 2 to the t plus 5 is equal to 7 over 6. So this is exponential form. So if I put it into log form, this would be log base 2, right? My base is 2, of the 7/6 is equal to my exponent t plus 5. So depending on your calculator, if you have the ability to take the log of any base, okay, you would do log base 2 of 7/6. If your calculator is older like mine, I don't have that feature, so I have to use the change of base formula. So I'm going to take the log of 7/6 divided by the log of 2. And just make sure you have your parentheses there. Okay, you want parentheses around the 7/6 and then divided by log of 2. And then our last step will be to subtract this 5. So once you calculate this, subtract 5 from both sides. I'll put it off to the side here. And you should end up with negative 4.778. So just follow your steps in order always. Always add or subtract if there's a constant added on to your base that's raised to the exponent. Okay, that's always step 1. And then if you have something that's being multiplied with the base to the exponent, do that division after adding or subtracting. Once you have the exponential form, put it into log form, and then from there you use your calculator. Okay, this last one, this is kind of challenging. This is actually a quadratic equation. If I rewrite this as e to the x squared minus 7 times e to the x plus 12, then it's a little more obvious because I have something squared. Think of this as x, right? X squared minus 7x plus 12. Okay, so that this does have quadratic form. Okay, so we can treat it like any other quadratic. If I can use factors of 12, that'll give me a negative 7. When I add them, I can factor this. The difference here is I'm not going to start with x and x, I'm going to start with e to the x and e to the x. So I'm going to subtract 3, and I'm going to subtract 4. Right, that gives me a positive 12, and when I add them I get the negative 7. From here we use our zero product property like we normally would. So I get e to the x is equal to 3. And e to the x is equal to 4. From here I can go into log form, so it's the natural log of 3 is equal to x, and the natural log of 4 is equal to x. So I have two solutions. So the decimals are 1.099 and 1.386. So if you see anything like this, think about that quadratic form. Okay. Remember, you're going to put it into the form e to the x and e to the x minus whatever constants give you that middle term. So when you see something like this, it should end up being factorable. That's the good part of it. If not, you could actually use quadratic formula. It gets a little messier, but you could do it. But again, it's going to be e to the x is equal to your quadratic formula, not just x. So at the end, when you calculate those values, you'd have to take the natural log of them to finally solve for x. So that concludes our lesson for today. If you have any questions, you can join me on Zoom any day. It'd be great to see you guys. So if you just feel like popping in to say hi, that's fine too. Okay, hope you enjoyed the lesson and enjoy the rest of your day.